All right, so in 13b, so 13a we'll be talking about logarithms in base 10 only. So everything we did had to be in base 10. Here we're going to talk about in base A, which means we can use any number as the base. So you're going to see we're going to be using bases of 2s, bases of 3s. So just as a bit of by way of description, this little number here, this subscript, that tells you the base that it's going to be in. Okay, that tells you the base that we're going to have it in. If it doesn't have anything written, like this example over here, then you assume it's base 10. Okay? If it has a number written there, then that's the base that we're operating in. So, write an exponential statement. So we have this logarithmic statement. Okay? Log in base 2 of 16 is 4. So if you put in your calculator, log in base 2 of 16 equals, it's going to pop out 4. So let's have a look at what an exponential statement for that is. The base is 2. Okay, so that's going to be our first statement. 2 to the power of 4 equals 16. Alright, so we're going 2, the base, to the power of this is equal to the log of which we're performing. Okay, let's do another one. The base is 3. 3 to the power of 2 is 9. And then over here, the base is 5 to the power of minus 2 is 1 on 25. Okay, so that's moving from a logarithmic statement to an exponential statement. Down here, we're going to do the opposite. We're going to start with the exponential statement and we're going to write a logarithmic statement. So for the logarithmic statement, this is going to be our base. So we're going to have log in base 2 of 32 equals 5. Okay. Here our base is 3, so we're going to go log in base 3 of 243 equals 4. And here our base is 2, log in base 2 of 1 on 8, log in base 2 of 1 on 8 is minus 3. Okay, so we can see the link going from there to there, and we can see the link going from there to there. We've done both. Okay, so that's just writing some statements, some linked statements. Over here, we're going to get right into what we were doing before. Now before, let's do this one first. Let's start with D. We've got log 100. So we know we have to express this number as a power of 10. That's going to be log of 10 squared, which simplifies to 2. So here we have to express that as a power of 10. That means here when we've got it in base 2, we need to express this number as a power of 2. So that's going to be log in base 2 of 2 to the power of 3. We've expressed it as a single power of 2, and so it's going to simplify to be the power. Okay, log in base 2 of 1 on 16, we need to express this as a power of 2. Well, that's going to be 1 on 2 to the power of 4, which is 2 to the minus 4. And we've expressed it now as a single power of 2 cent. So we're going to simplify that to be minus 4. Okay, now the base is 3. The base is 3, so we need to express this in terms of a power of 3. So we've got 1 on 3 squared, which is 3 to the minus 2. We've expressed it as a single power of 3, and so it simplifies to the power. Okay, we've done D. We can even have base in, well, here we've got base in terms of A, which means we don't know what this number is, but that's fine, because we just need to express this as a single power of A. So what we have here is we've got log in base A of A to the 1 times A to the half. Square root of A is A to the half. Now they're the same base, aren't they? So we can add those powers together. So that's going to be A to the power of 1 plus a half, which is A to the power of 3 on 2, 1 plus a half, 1 and a half, 3 divided by 2. And now we've expressed it as a single power of A, which is the base, and so it's going to simplify to be that fraction. Okay, log in base T of 1 on root T. So this is, we need to express this as a single power of t. It's 1 on t to the power of a half, which is t to the power of minus half. That equal should be there, so that equals is over here. T to the minus half, which simplifies to be minus half. We express that as a single power of the base there, which is t. Okay, so we've done that skill with base 10 logarithms. Now we're doing the same, but with a base of 2, 3, 5, even base a, some pronumerals. Okay, so that's all fine. There we're making exponential and logarithmic statements. And then here, we're going to solve for x. Okay? So we saw when we're solving for x, like let's just recap with this example. If we have log x equals 2, the way we solve that is we put 10 to the power of both sides. That's what we saw before, and so we have x is 100. Okay, we raise 10 to the power of both sides. So the important thing there is that the base was 10. Up here, the base is 2. So the way we're going to get rid of the log in base 2 is raise both sides, 2 to the power of both sides. Log in base 2 of x equals 2 to the 4. Okay? So now because that's the same base as the power we're raising it to, that gets rid of the log. This left-hand side simplifies to x, and 2 to the power of 4 is 16. Okay, here we've got log in base 3 of x. We're solving for x. We're trying to get x by itself. So we're going to raise both sides to the power of 3. So here we'll have x is 3 to the power of 1.5. 3 to the power of 3 and 2. Okay, base 6, 6 to the power of both sides. X is 36. So let's just do a very quick recap. Here I've got the graph of y is 2 to the power of x. Okay, so let's just put a few numbers on there. When x is 1, y is 2. When x is 2, y is 4. And when x is 3, y is 8. Okay? So if I said, what is log in base 2 of 6? Log in base 2 of 6. Okay? This means 2 to the power of what number is going to equal 6. Alright? And this is how they're getting it. They're going 6. Well, that's about here somewhere. 6 is halfway between 8 and 4. And so what's the x value it's going to correspond with? Somewhere between 2 and 3. Let's say 2.5. So log in base 2 of 6 is 2.5. What does this mean? It means 2 to the power of 2.5 equals 6. So we saw that with logarithms in base 10. Right? That's the link we saw with logarithms in base 10. That's the link we're seeing here with logarithms in base 2 or 3 or 5 or whatever the base is. Okay, so because we've seen this, log in base 2 of 8 is 3. Well, what does that mean? It means 2 to the power of what equals 8. That's what it means when we evaluate this. 2 to the power of what equals 8? 2 to the power of 3. Okay? So there we go. Let's see how we go with sum of 13b. Some of us are up to that, so let's crank through that.